Hi, welcome to my shop again. This is part 2 of the series on the natural edge hollow form. Part 1 was the outside and creativity and design elements. This is the hollowing and the laser use and reversing and things like that. Got some new tricks I'm sure you'll like at the end here. So let's get started. Now we're ready to drill. Using, if you can see over here on the other end of the camera, I'm using the pin to hold that Jacob's chuck in the quill that I just showed in the last YouTube clip. So it will turn the speed down a bit for drilling. Now when we're talking about hollowing systems, to hollow these out, people have different experiences, and so I wanted to get an overview, a back view of how quickly it is to set up and to take down the hollowing system. It's really no big deal. Just have it stored at the end of my lathe, stick it down between the bed, move the butterfly over, tighten it down, grab the boring bar, stick it in the handle, put my safety pin on, and we're ready to hollow. Okay, now we got the boring bar set up, we're ready to hollow. I'm going to fast forward through a lot of this. This hollowing is going to be the same as all the other hollowing that I've done. So we'll just start it off quickly here. And the first thing I did is drill the drill hole down where the drill hole is not the depth gauge. I stopped short of where I think the bottom is going to be, because I don't know until I finish the bottom exactly where the inside bottom is going to be. So don't drill the drill hole too deep. I always stop short. So the first thing was the drill hole. The second thing is I'm just going to do a cylinder shaped hole, and that's a shaving relief thing. If you watch when I pull the boring bar in and out, the shavings are going to pull out with it if it's a cylinder. Once I start to open it up into the larger diameter, then the shavings start to pack in there. So the first thing I'm going to do is a cylinder. So with the carbide cutter, it's always to the left. There's very little effort here with the carbide cutter. It's real easy and efficient. The small little cutter takes the right amount of wood at a time. So this is not hard on my body at all. We're just getting the center of that wood out in a hurry. Now the second thing I'm going to do is going to kick the cutter over on the side a little bit, so that it's going to undercut the shoulder. So at this stage I'm just starting to open up a space and get the waste wood away from behind first before I start to measure. Surprising how fast the shavings start to pile up in there and fight you. Now the waste area is out from behind inside the vessel now, so we're going to start working on the shape on the inside. We're going to start to measure this wall thickness right here and work our way down in and not go back again. So we're going to clean this up and make it nice on the inside and move from stage to stage as we go along. So to do that, we have to move the laser in position. So I'm going to use the long line of the card to indicate the place that I'm going to work and the angle that it's at. Bring it over to my laser, bring it over to the cutter and set the laser so that the gap is on the arrow line. Okay, now I'm going to make this so a little bit thick, maybe about a 1/4 inch thick, and that gives me a view of this edge is going to be a prominent feature in the design of the vessel, so I want to leave that edge a little bit thick and leave the vessel a little bit thick, not worry about getting down to a thin wall here because of that mouth opening. Now we get a closer view of where the laser is. It's just on the outside of that line, so the gap, it's all important to understand that that gap is my measuring device, the gap is my wall thickness, and that has to be 90 degrees through the wall, so that distance between the cutter and the gap is going to end up with my wall thickness. So now when I'm measuring inside, the laser's a dot. I can see where I'm at. I can see this is all open in here. This is all cleaned out, and the waste wood is gone. But I'm going to work just out here on the edge, and we're going to make a cut until that laser disappears, and then the gap is left behind. That shows us our wall thickness. Keep an eye on what I'm doing here with my fingertip control. It's very easy. Okay, the process here is to make the laser disappear, pull it towards the side of the vessel till the laser drops off, then the gap is left behind. So when the laser disappears, it means that the wall thickness is measured. We're getting a few little false readings here with the shavings. You can see the laser a little bit, but once you make the laser disappear, then you slow down and clean up the tool marks, and then move on to stage to stage to stage, and never go back to the top again. Okay, now we have to swivel the swivel around to undercut the shoulder. We've made a relatively difficult shape here, but the boring bar can reach any kind of shape, so it's no problem. And we're going to reset the laser so that the gap is 90 degrees through the wall. Here again, as we get deeper in there, we have to reset the swivel assembly, swivel it around so that the cut is able to reach, and every time we move the swivel, we have to reset the laser. Now here's an advantage for the laser over a camera kind of a system. The camera, you'd have to move the camera, have to redraw the line on the monitor and everything. With the laser, it only just takes 3 or 4 seconds to reset the gap again. So much more efficient. Same method here. Make the laser disappear, measure, measure, measure the wall, clean up the tool marks. Then go measure some more, clean up the tool marks. Okay, now I'm all done with this area, the top quadrant. I went stage by stage by stage, clean it up as I went. And now I'm going to skip this little corner here, and we're going to go out and start to measure on the bottom quadrant's wall. So I have to reset the laser now so that the laser line, the long line, is going to be the tangent along the wall. And I'm going to move it over and set the laser, see how much difference that is where the laser was before. I got to set it way around here so that it'll disappear off the wall, and my gap is 90 degrees through the wall, perpendicular to the wall. The gap is my measuring device. That gap has to be perpendicular through the wall. Okay, same method here. Make the laser disappear so that the wall thickness is measured, and we're going to get up close to where that corner is and be able to measure that bottom half of the vessel. The corner right between the top half and the bottom half will just meld in by hand. Just sweep you can watch the laser move across there and clean that little corner up. Now I'm done with the sidewall down into here, so I'm going to clean up this bottom and finish this all to where it's going to sit on the table on the outside of the other stage. So let's clean this up here. Alright, so now that's where it's going to sit on the table, and we're going to clean that up with a nice shear scrape so I don't have to sand it and meld it into the rest of the surface. Now we're back into hollowing, and I've got the laser set now so that there's no gap. It's set right at the tip of the tool, and watch very closely. You're going to be able to see the inside shape, and look at how bouncy and bumpy and stuff going on in there. But after a while, then you're going to watch the laser run just sweep across the bottom, very, very smooth and gentle arc across the bottom. Might want to rewind that and look at that again so that you can see how that laser's working. Now I've got it off of the faceplate, and we have prepared a donut with a big hole in it here that'll fit on the outside of the hollow form. I never want to capture anything on the inside. I always want to capture it on the outside. So that'll fit in here in this donut, and then I bring the tailstock up, and we're going to hold it just with a friction drive on this donut. Okay, now revolve it around and see that it's running pretty true. I'm not going to go back here and do any work, so it doesn't matter if it wobbles a little bit. Here's where it's got to be running pretty true, and I can move the tailstock position to make it run true, but it's going to wobble a little bit anyway because it's already sanded and dry and out of round. It's wobbly because of its drying. Now I've got it squeezed up against the donut so that it'll drive with just the friction. Now I'm just going to take the waste area where the screws are away and finish the inside of the bottom. I'm going to do it gently with small cuts and slowly so I don't stress this too much. I'm going to make a design change here at the last moment. I'm going to make the foot a little bit smaller diameter and a little bit taller because of that bark inclusion in there. So watch what I'm going to do. And I slowed the lathe down because the surface is not running true, and I'm following the bevel on that wobbly surface to make the cut in front of it. If I make the cut with the lathe going fast, where it was cutting it'd be true, and where the bowl is it wouldn't be true, it wouldn't match. So there's a little trick to use to clean that up, using the lathe going very slow and following the bevel. Follow the bevel on the wobbly surface and make a cut very slowly and gentle. Wait for that wood to come around and cut. Now I've got a nice true surface with the wobbly bowl now. So now we're going to go back on the inside of the bottom and get that nub off of there, get that center away so that I can finish the where it sits on the table. Just taking very light cuts again so that I don't tax this, and I don't want to break that little nub off either. The grain orientation is going every which way there in the burl, so I want to clean it up with a shear scrape. All I have to do now is take it off the lathe and carve that little nub off and finish the bottom with a little disc sander and be done. This shape is a little bit complex. Could have made it harder if I made the mouth opening smaller, but just wanted to show the use of the tools, and we can reach odd shapes like this. Thanks for watching. Don't forget to share it with the other turners in your club and your Facebook friends. I spend a lot of time and energy on the process, and the techniques are important, but you have to have the right tools to do it. So see my website for the tools that I offer, and we'll see you next time around.